All right, so I am going to start with all of the substitution problems. We're going to do all the substitutions first. All right, on test day, it will matter how you do the problem. Please only take one of these. On test day, it will matter how you do the problem. You have to follow the directions. Okay? So, how does substitution work? And I'm going to explain it to me how does substitution work. We get one letter by itself. And I suggest you always get the one by itself that's already by itself. So in this case, it's this X. This has a 2, this has a 2, this has a negative. Make your life easy. Get the one by itself that's already by itself. So X equals 4 minus 2y. We're going to move this 2y to the other side so that we have X equals. Then it's called substitution because we're going to take this guy right here and we're going to substitute him in for that X. X equals that. So this is going to get plugged in right there. So 2 times 4 minus 2y minus y equals 3. Everybody follow along? This is no different than what you've done your whole life, okay? So I'm not teaching you anything different. Now we'll distribute. Collect like terms. And now I'm going to solve. So I will subtract 8. So negative 5y equals negative 5. So it looks like y is what? But you remember you're not done. What do you have to do now? You got to go back and find x. And you go back and find x by plugging in 1 for y somewhere. You know, plug it in here or here. I like to plug it in here. Because sometimes I can do that in my head. 4 minus 2 times 1. 1 right there. 4 minus 2 times 1. It looks like x is going to be 2. And again, you can plug it in wherever you want. It doesn't matter. Put 1 in for y somewhere and figure out where x is. Okay? Alright. Who else came in? Now you came in. Gabby, Chloe, Priscilla. Now, when we write our answer, we're going to get in the habit of writing our answer like an ordered pair. Because when we solve a system, this is called a system of equations, when we are solving it, we are looking for where the curves intersect. These are lines. Y equals mx plus b. These are lines. They intersect at the point 2 comma 1. So we're going to write our answer as ordered pair x comma y. Okay? All right, let's skip down to number 3. We'll do all the substitutions first. So number 3 is another substitution. Now the good news is we already have a letter by itself, y. So I'm going to take this guy right here, and I'm going to plug him in right here. So x plus 1 squared equals 5. Y is x plus 1, so I'm going to plug x plus 1 in for y. Now let's not be goofy. What do I do right here? If you say distribute that 2, I'm going to smack you. If you don't distribute that 2, what do we have to do here? Foil. That's a foil. That is a foil. So x plus 1, x plus 1. So now I'm going to FOIL. So first, outside, inside, last. Now what? Combine my terms. So I'm going to have x squared, I'll put that one first, plus 3x plus 1 equals 5. Now what? This is a quadratic. But before I can handle it, I'm going to have to do what? Subtract 5. So I'm going to move that 5 over. So I'm going to have x squared plus 3x minus 4. Subtract that 5. Right? What do you want to do with that? Factor. Now, what if you don't want to factor, or if it doesn't factor?
You can subtract it.
You can use the quadratic formula, right, to solve a quadratic equation. Now be careful. How many answers did I get? 2. I got 2 x's. So I'm going to have 2 ordered pairs, and one of the x's is -4, and one of the x's is 1. Would you agree with that? So then what do I need to do? Plug it back in somewhere, wherever you want. Plug it in. I'm going to plug it in right here. If I put in 1 for x, y is 2. If I put in -4 for x, y is -3. And there are the 2 answers. This is 4. Why did we get 2 answers? Well, if you look at the original 2 equations, one of them is a parabola and one of them is a line. Is it possible that they would intersect in 2 places? Yeah, and that's what you're trying to do. You're trying to figure out where do they intersect. Okay? All right. One more substitution, number 6. Now we have to get a letter by itself. So it doesn't matter. I'm going to add y to both sides since my x is sitting right there so nicely. And then I'll take this and substitute it in right here. Are you with me, folks? You've done this before lots and lots of times. So 2y minus 2 times 4 plus y equals 3. So 2y, watch your distribution, minus 8 minus 2y equals 3. Don't these cancel out? So I'm left with -8 equals 3. So what does that mean? There's no solution. And again, guys, remember, what you are trying to do is figure out where these 2 equations cross each other. So these are both lines. Apparently, they don't cross each other. There is no point of intersection. They're parallel lines. All right, so those are the substitutions. Now we're going to the eliminations, which is my favorite. I always want to eliminate. what do we need to do to eliminate? Do not get a letter by itself. What do we do if we're gonna eliminate? We make two of them match. So like this is 2 and 5, they don't match. This is -3 and 1, they don't match. So I gotta do something to make them match. What would be the easiest thing to do? Multiply this guy by 3, because then I'll have 2x minus 3y equals 13, that's my top equation. And then 15x plus 3y equals 72. And the reason that it's called elimination is, now when you add, I get 17x, but what happens to my y's? They are eliminated. So 17x equals 85. Just add, straight down. So it looks like x is 5. Just like before, my answer is going to be in ordered pair, 5 comma something. What do I do? How do I find my y? Plug it in. Plug it wherever you want. It makes no difference. If I just plug it in this one right here, it says 5 times 5 plus y equals 24. So 25 plus y equals 24, and it looks like my y is -1. So easy. Would you agree? So easy. Okay, number 4, another elimination. Don't panic just because they're squares. We're going to do it exactly the same way. So decide what you want to eliminate. What would make that easy?
Multiply top by 2.
Multiply the top. Actually, if I'm going to multiply the top, I'd have to multiply it by -2. Because remember, when I add, they have to cancel. So I can do that. I can multiply the top by -2. So -2x squared plus 6y squared equals 22. And then 2x squared plus y squared equals 6. Remember, it's called elimination because when you add, they have to cross out. So one will have to be positive and one will have to be negative. So 7y squared equals 28, which means y squared equals 4, which means what? Y is, watch it, when you take the square root, what do we have to remember? Plus or minus. Plus or minus. So, y is either 2 or -2. When you take the square root, divided by 7, you square rooting. Square root of 4 is 2 or -2. Okay. All right. Now what? Plug them in. So I'll just plug them in this one. So 2x squared plus 4 equals 6. So I plug my 2, I'm doing 2. I plug 2 in right here, that makes 4. So 2x squared plus 4 is 6. So 2x squared equals 2, and x squared equals 1. Which means what's x? Plus or minus 1. So you can write them together like that, or you can go ahead and write 2 ordered pairs, because that's what that means. Now you're not done. Now you got to do the same thing, but you're going to plug in -2 now. You guys, what's going to happen when I plug in -2?
Cancel out.
Do I get exactly what's negative 2 squared? Isn't negative 2 squared 4? So I'm going to get exactly the same thing. So this one has a plus or minus 1 also. And again, it's fine to write it that way. It's fine to separate them. And in this problem, it's fine to write them together like this because you are counting all 4 of the points. That will not always be the case, but in this one it is. You can write it like this, you can write it like this, all 4 of these, or you can go like that. Why were there 4 answers? That's a lot. Well, the shapes that we have here are an ellipse and a hyperbola. Is it possible that we could have 4 points of intersection? Absolutely. All right, one more elimination. Can anybody see what I did as I was copying down my problem?
You already put things around.
I switch things around because if I'm doing elimination, don't I need them stacked on top of each other? So I just rearranged one of my equations so that I have them stacked on top of each other. All right, now I'm going to eliminate. So what am I going to do to eliminate? Negative 2 times the top. Now that's all the way across, boys and girls. So negative 2x minus 6y, negative 16. What happens when I add? This whole side cancels out, right? And this whole side cancels out. So I'm left with 0 equals 0. Now, wait a second. A minute ago I was left, I don't remember exactly, but it was something like 8 equals negative 3. That is wrong. So we said that one had no solution. What about this? Isn't that true? So this means there are infinitely many solutions. These 2 equations are the same line. Please do not say all real numbers because that is not true. Remember what we're trying to do. We're trying to figure out where do these shapes cross each other. Okay? They cross each other in infinitely many places, which means that if we were to draw them, there's the first line, and here would be the second line, right on top. They're right on top of each other. They are the same line. Okay? Does everybody see the difference between that and that?
Yeah.
As you can lose variables 2 ways. You can lose them and get all the x's and y's disappear, and you're left with that. Or all the x's and y's disappear, and you're left with that. All right, friends, that is 7.1. So guess what? Joyous good news. 7.1 will be due on Wednesday. 7.1 is due on Wednesday. And now we are moving on to 7.2. And we're going to start the vocabulary, but we will not get into it. We are going to embark on a new thing. And there is some new vocabulary that if we're going to do matrix operations and use matrices, you need to be able to understand the language that we're speaking. So, the first word is the word matrix. I promise you, this will be a test question. There will be a question on your test that says, define matrix. And if you miss it, I don't know what to say. Write it down, learn it. A matrix the word array, an arrangement, a rectangular array of numbers, arranged in rows and columns. So I'm going to give you an example. This is an example matrix. That is an example of a matrix. Notice it's what shape? A rectangle. What's it full of? Numbers that are arranged in rows and columns. Now that is going to be important that you can distinguish between rows and columns. So think of the bleachers. Rows go this way, right? These are the rows of the bleachers. So this is a row and this is a row. Think of the columns of the White House. Columns go like this. So this is a column, this is a column, this is a column. Okay? That's important. Because the next thing, next vocabulary word says, we need to be able to talk about our matrices in terms of their size. The dimensions of a matrix are rows by columns. This is the word by. It's like when you go to the lumber yard and you buy a 2x4. Right? Looks like this, 2x4. Not 2 times 4, it's a 2x4. This is rows by columns. So my example is what size of a matrix? 2 by 3. This is a 2 by 3 matrix because it has 2 rows and 3 columns. You've got to keep that straight. Roman Catholic, RC, rows, columns. Okay? All right. I'm going to pause right there and we'll pick this up on Thursday. I'll see you back on Thursday. Yeah, because, well, I see you tomorrow. Yeah, I'll see you tomorrow. We'll get